Hi guys, I'm sorry I'm not there. I forgot that I had a meeting this morning, but I will be back for Liberty Hour today. So if you do have questions over any of the notes, please feel free to stop by and I'd be happy to answer them. So yesterday we talked about how to create a scatter plot. Today we're going to look at how you would describe a scatter plot. And so it says, as in any graph of data, we want to look for an overall pattern and any striking departures from that pattern. The words we use to kind of describe the overall pattern of a scatter plot are direction, form, and strength of the relationship. Okay? Departures from the pattern will be what we call an outlier. This is an individual value that falls outside the overall pattern. We also want to look for clustering of values. If all of your values seem to fall into two clusters, that's definitely an important pattern to talk about. So words that describe direction would be positive or negative. We're really talking about the slope of our, linear pattern if we're talking about slope. Most of the functions that we will work with will have somewhat of a linear pattern. You can have other descriptors. You can have other shapes as well, but for the most part, we do a lot with linear. So the direction, you want to describe it as positive or negative. Your form can be linear, quadratic, cubic, exponential, curved, nonlinear, etc. Just a description of what you see as the shape. And then the strength will describe as strong, weak, somewhat strong, moderately strong, very weak, descriptors like that. And we'll talk about how you decide how to describe the strength later on. Strength really refers to how tightly grouped the points are. How close do they fit a straight line? The word we're going to talk about tomorrow is correlation. So if we look at these examples here, for this scatter plot, I would definitely say it's linear. It's a pretty strong pattern too. In other words, the points are very close to a straight line. The more they fit that actual pattern, the stronger it is. And then I would say it's negative because we definitely see it as a decreasing pattern. Example 2, I might describe this as quadratic. It's somewhat parabolic. You could also say nonlinear if you're not sure on, a specific type of function that you could land on. And I would say this is moderately strong. There's a little more space and the dots are a little more spaced out than the previous example. So moderately strong might be a good example or a good way to describe it. This one would be a little bit harder to describe as positive or negative because it's not linear, so it's not just headed in one direction. Example 3, we definitely can see that it is a negative pattern. It's a decreasing function. This, to me, really looks more like an exponential curve, so I might describe it as exponential. It really does, it's a pretty tight fit to an exponential curve, so I would say it's a strong negative exponential distribution. Notice down here we do have this one point. This would probably be an outlier. It strays from the pattern of the overall pattern of the rest of the dots, so that would definitely probably be an outlier. So when we interpret a scatter plot, interpreting tells us what the data suggests in real world terms. This is where we want to describe it in context. So an example might be the data suggests that the more hours a student studies for Mrs. Cole's AP Stats test, the higher grade the student earned. There is a positive relationship between hours studied and grades earned. So if we look at this example, this is looking at the problem from the day before where we're comparing body weight to pack weight. It says, describe and interpret the scatter plot. The y-axis refers to backpack weight in pounds and the x-axis refers to body weight in pounds. A strong interpretation would be there is a moderately strong positive linear relationship between body weight and pack weight. One possible outlier, which is the 187 pounds hiker, seems to be carrying less weight than the others. So we want to describe the pattern and also describe it in context. Another example, if we look at this is looking at a school's mean SAT math score and the percentage of students that are taking the SAT. So notice here, this is a little more of a curved relationship, and it definitely seems to have kind of a negative pattern to it. The points aren't as close together, but it's a definite pattern, so I might describe that as moderately strong. So there is a moderately strong negative curved relationship between percent of students taking the SAT and the mean math score. There are two, also, if you look, there's kind of two distinct clusters that definitely kind of groups here, and then it definitely kind of groups over here. And there may actually be at least one outlier. This potentially could be an outlier. This one is probably an outlier as well. And so I'd like you to kind of stop here with the notes. We'll talk about correlation tomorrow. With what we've covered in the notes yesterday and today, you should be able to complete problems 1 through 7 in the section 3.1 book exercises.